two concepts, convection and plasma. Which of these do you think has more to do with what's happening in our atmosphere in terms of storms, in terms of wind? Well, if you ask a meteorologist that question, they're going to tell you convection. But if you ask me, it's going to be plasma. Let me suggest a common observation that you could do that can show right off the bat that convection is most probably wrong. The vast majority of the warm, moist air on this planet is along the surface, and the vast majority of cool, dry air is high above us, a couple thousand feet above us. Now, why is that an important observation? According to convection theory, cool, dry air is heavier than moist, warm air, and convection is the process that rules the flow of air on our planet. And so, if what they were saying was true, there would be a constant process of warm, moist air rising up, and we just simply don't see that. And the math is pretty straightforward. It involves Avogadro's law. I suggest you look that up, but basically it's just saying that that any particle in the atmosphere, all the particles will have about the same amount of space between them. So if you know the weight of the particle, you can get a good understanding of the amount of weight per volume. Now, H2O has a molecular weight of 18. Air has an average molecular weight of 29. You do the math on that, calculating, you have to kind of remember though that moist air makes up at most maybe 3% of the particles in the atmosphere. You do the math on that and you end up that the weight of moist air, assuming it contains steam, you know, really monomolecular H2O, and the weight of dry air according to this calculation is actually heavier, but it's only a 1% difference. So it's a really slight difference that they're trying to tell you that this is what pushes the flow of atmosphere on this planet. And then here's the big kicker. Here's the thing that really makes them look kind of dumb, to tell you the truth. And that is, they're assuming steam in this. The basic reason is that moisture in our air, contrary to what a lot of people believe, is actually in little micro droplets. That's true even when the air is clear. It's little micro droplets, but these little micro droplets have more mass to them than do the air molecules that those micro droplets replace. The real reason meteorologists hang on to that notion that moisture is steam in our atmosphere, it's partly because without it they don't really have another explanation. But there's actually a more deeper understanding that has to do with just common sense. And that is just simply the observation that there is moisture in the atmosphere, and the fact that it doesn't just simply fall out. Now let me explain now. The reason, it's well known that the reason H2O has the high boiling point it has is because of its polarity. Now, if its polarity is so strong after it gets released in the atmosphere that it would come together and stop being steam, then the common sense is that it would continue to do that. In other words, if you have a molecule that has high polarity, if 10 of them get together and form a little droplet, they should have 10 times the polarity, shouldn't they? And since we can see that there is water in the atmosphere, we know that that isn't the case. And so that's the rationale. Since there is water in the atmosphere, there must be some cause that's keeping the little water molecules apart. The thing that I think most people envision is just simply that there's enough air molecules in there that once steam is created, once monomolecular H2O is created, it creates enough distance that it overcomes the polarity of the H2O molecule, and that explains why there is steam in our atmosphere. And that's really important, because without that, then the convection model completely breaks down. And if the convection model breaks down, then we don't really have any way of explaining how water gets so high in our atmosphere. And we also don't have any way of explaining the energy of storms. Well, I'm saying that's wrong. I'm saying that this notion that water will get together and be cumulative, have cumulative strength, is mistaken. And I'm also saying that there is another way to explain how moisture gets up high in the atmosphere. And I'm saying there's another way of explaining where the energy of storms comes from, and it all has to do with plasma. And so one day I was watching Nova, and Nova's, the episode was about deadliest tornadoes. And at the time, I had already come to the realization that this notion that convection has anything to do with our atmosphere is pretty much nonsense. So I was looking at it. I was kind of looking at this TV show, kind of looking for clues, and I saw one. And let me describe to you what I saw. I saw the vortex or the cone of a tornado, and the concept that came to my mind was that is plasma. You can just see it. It's relatively thick air, and it's highly activated in some way. It's got some energy going on with it, and it is forming a tube, and that tube is coming down from the sky. And as I saw it, that tube most likely connected to the jet streams. And the jet streams are another thing that meteorology doesn't really have a good explanation of. So I kind of put those two together. I said, tornadoes, jet streams, same thing. Plasma. Also, as I saw it, water must have something to do with the plasma, because that tied in the fact that storms were so wet. And so, this all comes down. Storms, tornadoes, plasma, tubes in the atmosphere. And these tubes come down, they cause storms, and when they do, they pull moisture up in the air. That explains how moisture gets up high in the atmosphere. This all kind of fit together for me. And so I said, why don't I go out looking for something that will confirm this, or something that will substantiate this? And around that time, I came across another TV show. Now, this second TV show I saw, if I remember, it was History Channel's Modern Marvels, and it was talking about water. And one of the things it mentioned, first of all, it was pretty fascinating because there's all these what they call anomalies of water. One of these anomalies was what they call surface tension. And I thought about that in context of my notion that there could be some kind of a water-based plasma in the atmosphere. And I kind of came up with a little pseudo-principle, I guess you would call it. And that is, okay, you have this surface tension. Now, if there's some way in the atmosphere that you can maximize the surface of water, it would seem logical that you would also maximize its surface tension. And if you maximize its surface tension, maybe this explained the plasma that I saw as being part of tornadoes. So that notion really made sense, though, when I kind of put two to two together, because one of the aspects about tornado genesis, one of the realities of it, causal realities, I should say, is this notion of wind shear. And specifically, we're talking about wind shear between two bodies of air that are going different directions. One being relatively moist, usually down low, and the other one being relatively dry, and usually the moist one is warmer and the dry one is cooler. And they're either going at cross angles like this, or they're even going directly against each other. And then I thought very carefully about how that cross angle might maximize the surface area of any water that's in that warm, moist air. And the only thing I came up with, well, you know, first of all, just the fact that there's two bodies of air clashing, that does kind of suggest that there's energy there with respect to causing something to happen with the water molecules. But it didn't really seem all that sustainable, you know, it would just be on and off. It didn't seem like it was the kind of energy that would cause the existence of a plasma that has some stability that could form a cone. But then I thought about it a little bit longer, and I said along that surface, on a molecular basis, if one is dry and the other one is moist, those droplets in the moist part are going to start spinning. And if that continues long enough, that spinning is going to get faster and faster and faster of those little micro droplets in the moist layer. And as they spin, maybe there's some way that they would elongate into kind of a polymer, really, kind of like a thread of water. And you know, if you imagine this happening to trillions of molecules, might this explain the basis of my putting together my notion? Might that explain how the surface area of H2O is maximized in a sustainable manner? And might that allow for the formation of this plasma based on the notion that if you maximize the surface area of water, you maximize the surface tension? So in an effort to put together all these observations, again, water's boiling point being so high, much higher than is available in our atmosphere, yet it's so passive up there in the atmosphere when it's in a droplet form. And lastly, then under certain conditions where its surface is maximized, it has the ability to form this really thick plasma. And I came across the notion of hydrogen bonding. Hydrogen bonding simply says that the water molecule's shape dictates that this oxygen molecule here sucks down more of the electrons, making this more negative and making these two little Mickey Mouse ears here more relatively positive. And that creates this kind of a hydrogen bond going on here. But that didn't really answer any of my questions. So I wondered if there might be something more going on with hydrogen bonding than just that. And this is what I came up with. I wondered if hydrogen bonds themselves might in some way have something to do with neutralizing the polarity that's in that's in water molecules. And the logic works out as such. Here is a water molecule that has two hydrogen bonds on it, and that is the liquid form of water, and that would explain why when water is in a liquid form in the atmosphere, a droplet, let's say, it's relatively passive. It has no more polarity because that polarity has been neutralized by these two hydrogen bonds. And this would be a steam molecule, and of course this would be one that wouldn't really exist in our atmosphere. But because its polarity is so high when there's nothing attached to it, that explains why the boiling point is so high. And then this one is, well, this one right here is what I imagine the surface tension would look like. In other words, this had one molecule attached to it, but it still had some degree of polarity. Note that these numbers in here indicate the polarity. In other words, this had half the polarity of the steam, but since it had some polarity, this was a hard connection. And so that explained how water has this surface tension and the ability to form hard bonds and some degree of electromagnetic activity that I would associate with some kind of a plasma. So I'm referring to this as their polarity coefficients, and I'm saying that polarity coefficient is variable, and it gets neutralized when bonds are complete. It's fully activated only when bonds aren't complete at all, and it's in half polarity coefficient. It's in half polarity when there's only one associated with it, and this allows the pieces of the puzzle to come together to explain what's going on with water in the atmosphere. It allows us to understand why there's that high boiling point and why there's no steam in our atmosphere. It also explains why those molecules don't come together, because they're pacified once they go into little droplets. And if those droplets can somehow be elongated, they become hard, and that explains not only how they are electromagnetically more active to effectuate kind of a plasma effect, but also it explains how those little threads of polymer, water, stay intact and don't just go flying off, because as that little polymer elongates, it activates the polarity, it activates a hard charge between them. So the next thing I did was started looking into water science. And I was specifically looking for confirmation of the mechanism that I envisioned, you know, this notion that H2O polarity was variable, and that that hydrogen bonds were the mechanism that caused that variation, that caused that polarity to go up and down. Specifically, you know, hydrogen bonds neutralize the polarity. And I actually expected to find it. I expected that this was something that was well understood, and that it was maybe a little bit obscure, but if I was to look hard enough, I would find evidence that substantiated it. But it turns out, not the case. Not the case. I didn't find anything that would suggest, or no one explicitly indicated that any kind of mechanism like this was possible. Now, being a person who is naturally kind of cynical of authority, which I guess in a sense, which is what originally got me to suspect that meteorologists really didn't know what they were talking about in the atmosphere, and since my research confirmed that, I felt, you know, pretty confident about that. I also suspected, hey, maybe these water researchers really don't, well, maybe they just missed something. Maybe they missed something. So I started looking into polarity, and I kind of already mentioned part of it, which has to do with what they call electronegativity differences. Let me explain that a little bit more explicitly. Now, electronegativity difference, here's a water molecule. It just simply says that this oxygen molecule is more massive, and it pulls down electrons onto this molecule here, and you know, making these more positive and this more negative. But a lot of molecules have this ability, and they aren't all polar molecules. And let me give you a perfect example. That's the methane molecule. It's very similar to the water molecule because it has hydrogen, covalently bonded hydrogen bonds, or covalent bonds with hydrogen atoms. Now, what's different though about the carbon or the methane molecule is that it is not it's not a polar molecule because of the fact that these are all arranged symmetrically. Now, part of the limitations when it comes to explaining something like this is the fact that you have a two-dimensional piece of paper here. In reality, this is a four-dimensional thing, and it involves what they call a tetrahedron. If you were to twist two of these molecules like this, you would see that this is actually a tetrahedron that goes like that. And there's a tetrahedron, you can think of it being a three-sided pyramid with a bottom. It has four corners and four sides, and each one of the corners of the tetrahedron on the methane molecule is filled with a hydrogen atom. Now, the water molecule also has that same underlying template, which is based on what they call the steric number, and there's a whole theory about this called Vesper Theory. I suggest looking that up if you're interested in understanding how electrons are arranged in the outer valence shell of the molecules that make up most of our environment, things like oxygen, carbon, nitrogen, those kind of things. Now, with oxygen, a little bit more of a massive molecule, so it attracts more electrons naturally, and here are the two, what they call non-bonding pairs of electrons for the water molecule. And again, if we were to really imagine these things, it would be more of a tetrahedron like this. You would twist these like this. But this is a polar molecule because of the fact that it can't really form covalent bonds down here, whereas this one can, methane can form covalent bonds on all four corners. It therefore is not a polar bond or a polar molecule, a dipole. Now, I started asking myself, though, some rhetorical questions. I said, what if, kind of a thought experiment, I said, what if we were to remove the two hydrogen atoms off of this, artificially in some way? Wouldn't this turn into a polar molecule? And then I took that a step further and I thought, what if these things were actually movable? We can envision the polarity in here actually changing, going up and down. And I took that a step further and I says, well, what about the, if that'll do that here on the, on the methane molecule, on the carbon atom, why wouldn't it do the same thing with oxygen on the water molecule? And why would it even matter whether the bonds that formed down here were covalent or not? As I thought about it, it really wouldn't matter. It wouldn't make any difference at all, because it has to do with what's happening to the electrons on here. And the electrons don't know the difference between a covalent bond and a hydrogen bond. And so that kind of answered the questions. You can think of it this way. As hydrogen bonds are formed in water, they neutralize the polarity. So if there's two bonds here, two other H2O molecules come up and form a hydrogen bond right here, the polarity here on this molecule is going to be 0. And if there's 1, the polarity is going to be 2. Which, if you remember, gets right to what we were discussing previously. Zero, 4, 2, and the concept that it all comes down to, and this is the thing I think the people in water sciences missed, is that they may have understood electronegativity differences, and they may have even understood the fact that symmetry, it's hard to believe they don't have some understanding of this being asymmetrical and this being symmetrical, and that being the underlying cause of the H2O polarity. But here's the thing I think they didn't quite take into account. Symmetry is not a constant, it's a variable depending on the degree to which hydrogen bonds are formed. And that answers the question. That tells us why H2O has such unusual behavior in the atmosphere, and of course in all contexts, and why it has, well, let's go over that again. It has the high boiling point. It has the high boiling point because it has that high polarity when it's on an individual basis. It's passive anytime it's in a liquid form. By that I mean its polarity has been neutralized. And that helps us understand another kind of quirkiness of H2O, and that is why it is so fluid. See, when this is 0, these things just kind of float here, these hydrogen bonds. And as they pull away, the polarity would start to return, so they could never quite get away. H2O is, in a sense, kind of it's a pseudo gas and it's a pseudo liquid, because the more it becomes a liquid by creating a bond here and coming together, the more it zeroes this out, which allows it to float away again. So water really does have kind of a dual personality, and it all comes down to the fact that H2O polarity, or the polarity, is variable. And this is maybe, I think, the most interesting one of all, especially with respect to understanding the possibility that there's any kind of a plasma going on in our atmosphere, and that might explain some of the phenomena like tornadoes and jet streams and such. And since this does allow for a more electromagnetically active and a harder bond, we can now have a mechanism to understand how, when surface area of water in the atmosphere of liquid water is maximized, it produces a more electromagnetically active entity explaining the underlying basis of the plasma. And so just this last November and December, after looking into the literature and finding out there was nothing on this subject, I decided I would write a paper on it, and I went ahead and did so. You can look up my paper, and there's also I've had some correspondence with a number of the experts in the field, and you can see, you can find that. Let me tell you how you can find it on the internet. First, just simply go to Google, and then in the search, just type in groups, and that'll take you to something called Google Groups. And then do a search under this particular news group. It's psi.physics, spelled just like that. And then once you get there, you can do a search under my name, which is James McGinn, or you can actually search the main paper. This is the one, though, this is the main paper that really gets to the heart of this mechanism. It's called Hydrogen Bonding as the Mechanism that Neutralizes H2O Polarity. And you can also see on there that I've had a few conversations with some of the people who are, shall we say, big shots in the field of water science. Among those is Richard Sakerly of Berkeley. Another one is Alan Soper. I forget where he's from, some place in England. I forget exactly what the organization is. And there's a number of other PhD students who I've had some conversation with. But you should be able to find all of those conversations on that news group, and just by searching my name. But you'll see, as of yet, what I'm saying is considered controversial. And you'll see that no one really has a dispute with anything I'm saying. The mechanism I'm indicating there, makes perfect sense. It just isn't something that they, it's new. It's not something they've thought of yet. So keep that in mind, but I hope you get a chance to go over there and take a look at that, and then feel free to leave a comment. Thank you. And so just this last November and December, after looking into the literature and finding out there was nothing on this subject, I decided I would write a paper on it, and I went ahead and did so. You can look up my paper, and there's also I've had some correspondence with a number of the experts in the field, and you can see, you can find that. Let me tell you how you can find it on the internet. First, just simply go to Google, and then in the search, just type in groups, and that'll take you to something called Google Groups. And then do a search under this particular news group. It's psi.physics, spelled just like that. And then once you get there, you can do a search under my name, which is James McGinn, or you can actually search the main paper. This is the one, though, this is the main paper that really gets to the heart of this mechanism. It's called Hydrogen Bonding as the Mechanism that Neutralizes H2O Polarity. And you can also see on there that I've had a few conversations with some of the people who are, shall we say, big shots in the field of water science. Among those is Richard Sakerly of Berkeley. Another one is Alan Soper. I forget where he's from, some place in England. I forget exactly what the organization is. And there's a number of other PhD students who I've had some conversation with. But you should be able to find all of those conversations on that news group, and just by searching my name. But you'll see, as of yet, what I'm saying is considered controversial. And you'll see that no one really has a dispute with anything I'm saying. The mechanism I'm indicating there, makes perfect sense. It just isn't something that they, it's new. It's not something they've thought of yet. So keep that in mind, but I hope you get a chance to go over there and take a look at that, and then feel free to leave a comment. Thank you.